Hello, this is mile marker 1 in regards to fractions, specifically adding and subtracting fractions with unlike denominators. Let's look at the problem 7 over 8 plus 3 over 20. First, are they speaking the same language? Well, one has a denominator of 8 and the other is 20. So no, they're not speaking the same language. Imagine one fraction is speaking French and the other one is German. So we need to find a common language. To do that is step 2. We use the ladder method to find the LCM, or least common multiple. Our focus is on the denominators, so let's look at them. We have the 8 and 20. What we want to do is use the ladder method, so we create this big L bracket. We look at the two values 8 and 20, and we want to find prime factors that can divide evenly, not into one, but into both values. And so since they're both even numbers, let's try a 2. A 2 can divide evenly into 8 4 times. 2 can divide evenly into 20 10 times. And so we're now going to be looking at the values 4 and 10. Do they have any common factors? They do. Since they are both even, let's try 2. 2 can go into 4 2 times. 2 can go into 10 5 times. Now, just looking at the 2 and 5, are there any other common factors? Well, there's not, so we are done using the ladder method, and we're going to look at the values on the outside. We have a 2, a 2, a 2, and a 5, and if we multiply all the values on the outside, we will find the LCM. And this is the common language that both the fractions can speak. And so what we're going to do is look at the original fractions in their current language. They're French and German, but we need translators so that they can speak the same language. Looking at the first fraction, 7 over 8. That 8 is not quite a 40, so we have to translate it into that value. 8 times what would give you 40? Well, that number would be a 5. But we have to maintain the value, so whatever you do to the bottom, you must do to the top. We're trying to create an equivalent fraction. And so we see in the denominator 8 times 5 is 40, and so the numerator 7 times 5 is 35. Now we focus on the second fraction. It speaks a totally different language, so it needs a different translator. With 20 in the denominator, 20 times what would give us the common language of 40? And that value happens to be 2. And we have to be fair. What you do to the bottom, you have to do to the top. And so 20 times 2 is 40. 3 times 2 is 6. And so now we have the two fractions speaking the same language, and so now we can do the original addition. And since they are speaking the same language, we keep that common denominator, and now we add. 35 plus 6 is 41. Let's look at another problem. Okay, this time we have 8 over 15 minus 1 over 4. So first we check. Are they speaking the same language? And the answer is no. So we're going to look at our denominators on the side, and we're going to do the ladder method. I have a 15 and a 4. Now I want to see if they have anything in common. Can any number evenly divide into 15 and 4? 2 doesn't work, 3 doesn't work, and 5 doesn't work. So since there's no factors, we are going to simply multiply these two values, and 15 times 4 will be 60. 60 will be your common denominator. So what we're going to do here is we are going to keep the original fractions, so 8 over 15 with its translator, minus 1 over 4 with its translator, all in the hopes of having that common denominator of 60. So now each fraction has its own translator. For the first fraction of 8 over 15, I need to focus on what 15 times what would give me 60. And so it turns out the translator would be 4. And so 15 times 4 gives me 60. 8 times 4 is 32. Now the second fraction needs its very own translator, and so we focus 4 times what would give me 60. And it turns out it would be a 15. But we have to be fair. What you do at the bottom, you do to the top. And so 4 times 15 is 60. 1 times 15 is 15. Now we see the two fractions are speaking the same language, and so we want to keep that common denominator. And now we get to actually do the subtraction that it asked us to do. 32 minus 15 is 17. And both values it's not going to reduce because they have nothing in common. That would be your final answer.